Hello everyone, welcome to TechSpark. My name is Anush Kumar, Java trainer, having a 5+ years of IT experience. This is the advanced Java session number 14. So today's class agenda we will cover a theoretical first part. First, that is what is microservices, microservice architecture, what is Kafka architecture, RabbitMQ and RabbitMQ architecture. In these classes, we will cover what are the flows in microservices, what are different types, different way of communication between the microservices, what is Kafka architecture and flow, RabbitMQ architecture and flow. We are going to cover all this topic theoretically, and in next classes we will going to create one application in microservices, one application with the help of asynchronous communication. Okay. So what is first microservices? Okay. Microservices is an architectural style. Means we are till now we have created a monolithic application. Means what is monolithic application is we have created one application in one server using one database. Okay, now in microservice we will create more than one application. Okay, and different servers or different host name or port name we will give. Different database will be there, like we have created one application like product service. Okay, it have one database and its port number is 8081. Similarly, we will get another service like product service, that inventory service. Okay, it have different database, different host number. Then third service like card service or email service, it have different host number database. So all these service have different host name, port name, different databases. Okay, and then we basically make the all three communication to interact with each other, take the data from each other and show the result. Okay, so make a communication between the all three microservices. So that is basically known as microservices. Okay, when we are creating more than one services and make a communication between them. Okay, that is called microservice. A microservice is a architecture style where an application is broken down into smaller and independent service that communicate with each other over the network. Okay, with the help of HTTP request or message broker. Okay, means with the help of REST template, REST APIs, we can communicate, or with the help of message we can communicate. Okay, we have seen till now the communication with the help of REST template. Okay, means we have created REST template. Now with the help of REST template, earlier we are created REST template and communicating with the front end application. Okay, that is also you can say as they are the microservice, because back end one application, front end another application. Okay, so each microservice handle one specific business functionality. Okay, like you are creating a like e-commerce application or some employee management application or car insurance or anything. Okay, so basically you will divide that application, like you have different module. One module for working in the login, one module working for security, one module working in the emails, one module working for the employee or customer data in this way. So that every module you will create a separate application, separate web app. Okay, so that is called. Okay, so each microservice handle on a specific functionality. Okay, then has its own database, is independently deployed. Okay, because every microservice you can deploy according to your need, different servers. Okay, different port number, and can be built usually different language. Okay, what is the good things about microservice? Like you are Java developer. Okay, now you basically work on a Java application. Okay, some according to the current future market, now the demand of Python and Python development is growing on. Now they are also developing an application. Now you want to communicate with the older application and new application. So older application is developed in Java, a new application is developed in Python or any other language. Okay, so you want to communication between those two languages. So how you will communicate? With the help of microservices. There are two microservices. Now with the help of the APIs, the REST APIs, the messaging, you can communicate with the two services which are built in different language. One application built in Java, one application built in Python, Ruby, and other language. So they can communicate with the each other with the help of architectural microservice architecture. Okay, Now, what is the benefit of microservice? Like, you have created a microservice. Earlier, what happened in monolithic? We basically we have created our application in one server, one database. If server goes down, whole application will be goes down. Okay, you can. So scalability is not much in monolithic. Okay, but here benefit of microservice, you can scale every microservice independently. If one microservice goes down, no problem. Other microservice keep on working. Okay, better for faulty isolation. Okay, faulty isolation means in monolithic, if our service goes down, the whole application basically goes down. Okay, in your console, is something is bad happening or error come, your application is currently not running. But what happened here, you are have different microservice, different work, they will basically running on different port number and host number. So there will be no effect on whole services, because application is not working, but other four applications will all keep on working. But that is the benefit. If the other one microservice fail, the other will keep on working. Technologies, we can different microservice can be written in different languages like Java and Python. Fast time to market means there will be different teams working on different application. Okay, so basically it will goes faster and quicker development to the market. Okay. Also, there is one disadvantage is because a microservice you will basically need a large team. Basically, team one, team two, team three. Team one is working on one small module of your e-commerce, like e-commerce project. Okay, you have divided the four module, means four features, four applications you have. One application you are working on the API, user login, logout. One application is payment, one application is card, one application is email and user database. So you will basically need four teams which are working on different applications. It is faster to market, but the maintenance cost and the other all expenses basically increase. That is the disadvantage also. Easy to maintain and update. Okay. Now, what is the disadvantage of microservice? Managing the multiple services, communication, deployment is complex than the single monolithic application. That is true. Okay. Network latency means more network, because different more application, more network will be needed. So the performance may be slow. Okay. The data management, because every application will have their different databases. So data management will be needed. For that, you resource or employee will be needed. Deployment means you need more spaces, more thing, means you need a DevOps tool like Docker, Kubernetes, CI/CD pipeline for scaling deployment. Okay, for automation, test and deployment. See, okay, but testing challenges, because their application is used bigger, so testing is bigger. Communication overhead means you need to handle the REST APIs, because different application are communicating with the help of API message brokers. Sometimes you will get errors, they are not communicating, then you have to work upon them. So that is a communication overview. So what is basically microservice? Now coming to microservice architecture. So what is microservice architecture means? A microservice architecture is an entire application is broken into smaller, loosely coupled service where each service perform a specific business functional and communicate via APIs or message system. So, like for example, you have a user service that manage the user, product service that handle the product info, order service that manage the order, payment service that handle the transaction. These are four different types of application of simple one application. So this is a we have broken down one application into these four modules, four features, four application. Okay. Now each service is deployed independently, have their own database and code base. They have their own APIs. Okay. In microservice architecture, this is a simple example. Like we have a this is the figure. Okay. First, let me define some terms related to this architecture. First, let understand what are the terms here and what are they are doing basically. Like we have in component in microservice architecture, we have a component like API gateway. API gateway is basically single entry point whenever a client or customer request The request basically, let me explain this. Like if a client customer send a request means if they in a mobile application, web application, or any types of UI, they request. Okay, then request basically goes to an API gateway. This API gateway. Okay, this API gateway basically what it will do. It is a single entry point. API gateway is a single entry point that basically take in the request and send the request to respective different microservices. Okay, this different microservices. So what is that? A client from web application, mobile, postman send a request. Okay, then request first hit the API gateway, this API gateway, and API gateway act as a single entry point for all the requests from the client. Okay, API gateway basically responsibility is it will basically route the request to it will basically route the request to different microservices. These are basically different microservice. Like catalog is one microservice is working on one feature. Shopping cart, discount application is basically give the discount ordering. Okay, these are different four different microservices. Okay, the request is coming from mobile or web application, goes to API gateway. And API gateway basically route the request to different microservices. It API gateway also work as a load balancer, means this load balancer means when they are you have huge number of requests coming, okay, from different things. Then API gateway work as load balancer. It will distribute the load to different services according to their request. Okay, so that is the load balancing. To basically it will distribute the traffic across multiple instances. These are basically instance of a service to avoid the overload. Okay, so that one service may not get overloaded. Okay, that is the overloading. Now it will this API gateway also work as a authentication and authorization, means it verify the user is allowed to access the request or services thing. Then it will basically whatever the request is coming, the API gateway will basically filter the request and transformation, means okay, modify the headers, log, request body. That is also a duty of API gateway. Okay, API gateway also work as a rate limiting. Rate limiting means you can write a code inside API gateway. How many times someone can hit the request, okay, by client or endpoint. That is the rate limiting, okay, in your APIs. Then it also work as a preventing the cascading failure. When it is work as a breaker integration. It also basically done with the help of API gateway, means prevent the cascading failure. Okay, that is the thing. Then this APIs here, API, there is one more thing that is a config server here. So basically, these are different types of application. They have their configuration file. Every server configuration file is kept in one place in configuration server. And where is the configuration server? In Git file, you have a storage there. You can store the configuration server, and you can basically access all the application configuration server from one place and update and modify, import, export. Okay, because it is kept in the one place. That is a configuration server. So API gateway does not hard code your URL. Okay, it use the service discovery to dynamically find the application with the help of a host name and post name, because every application have different host name and port name, because every application will work on different port number. Like one application working on 8081, 8082, 8083, 8084, and different databases. So this API with know which request to which request will be sent to which application with the help of host name and port name of the application. Okay, this allow the service. Okay, this allows the service to scale dynamically and change their location and IP without manually updating. Okay, that is the thing. Now these are different microservices. Now some microservice may got errors or do not work or fault. Okay, some fault occur. So for that we have a circuit breaker, like and you want to know where the fault occur or not. Okay, so we have a one thing called a circuit breaker, or that is a resilience 4J or district dashboard. So And when we create a microservice, we can create a history dashboard and we can register every microservice there, and we can see the different information with the help of history dashboard. So in circuit breaker and history, which we implement history dashboard, monitor the calls to a downstream services. If a services is down or too slow, the circuit open to prevent the repetitive failure. Can return a fallback response or error message immediately. If some message basically fall, it can send a fallback mechanism or message to the next microservice that it is not working, and that will be basically sent to the application. It basically help in fault tolerance and resilience. So microservices, each services handle a specific business functionality. Like some is working on the catalog user, some is working on the shopping cart order, some is working on discount. Okay, this basically service are basically a stateless and communication via a REST APIs. We have one more thing for communication, gRPC, then message for messaging. Okay, so this is the thing. And for like one way of communication with the help of REST API, and second way of communication with the help of the asynchronous communication, means with the help of message broker or message. Okay, for a synchronous communication, we can use REST template, REST API, web client, Figma. Okay, or for messaging, we can use Kafka, and asynchronous communication, we can use Kafka RabbitMQ. That is basically used for asynchronous communication, where an application basically there will be a producer, consumer, and in between there will be a message broker that can be a Kafka or RabbitMQ. Basically, producer and consumer will be there. They will work on the public and subscribing to the topics. Okay, public subscribe model. We will see what are the things. Okay, so this is the basically for tracking a microservice, you can use Jenkins. Okay. For configuration, Spring config file, you can use Spring Cloud config. Okay. And you can use different types of database according to your need. Okay. So this is all about the microservice architecture. Okay. Now coming to uh, how they basically communicate. But there are two ways of communication between a microservices. One is a synchronous communication. We can where we are generally creating a REST API, REST API. Okay, then we can use a REST template to communicate. Web client, Open Figma to communicate between the two application like order and payment services. One order, and after the request will go to payment, and this way. And second is asynchronous communication, where we are using with the help of message and topic publish and subscribe model, that we use Kafka and RabbitMQ. Okay, background task, event based order created send, that is the example of. Okay, so synchronous, we use HTTP protocol to make over HTTP request for a microservice over other microservice. And asynchronous, we use message broker to communicate between the different microservices. Okay, so we have seen. So so in our microservice, we have what? API gateway. So API gateway basically route the request, rate limiting, load balancing, authentication, authorization, basically done with the help of API gateway. API gateway, single entry point. Okay, all the requests to what is the you have in Spring, we have a Spring Cloud. There you can use Netflix API gateway, Amazon API gateway. This you can implement. Okay, then we have service registry. All the microservice will register to a service registry, and API gateway will basically discover the all microservice from service registry using the host name and port name. Okay, then we have a config server. What in config server is? Config server is space in your Git repository or Git database, where all the configuration file of your microservice basically stored in the Git config server, and you can import, export, update in one place. Then if some microservice fail, then we have a distribution tracking. What is distribution tracking? In order to maintain the log and complete the log hierarchy at a particular HTTP call, we can use a distribution tracking. Okay, like Jenkins, okay, Sleuth. These are the And we have a Spring Boot, we have a Spring Cloud, from where we can basically import this all these services. Okay, and we can add and work upon them. Okay, this is the a example of the microservices. Okay, if some one more thing, if some microservices fail, so how we are handling with the help of a circuit breaker, we are handling if some microservice fail. Okay, so in circuit breaker, we have a fallback method, circuit breaker pattern, and retry mechanism. So these are different types of method. Okay, so fallback method, what happen when a one when in fallback method, if they are different microservice. Okay, if one microservice goes down, okay, if like this, use 1, 2, 3, 4. These are 4 microservices. Okay, if one microservice, that is this is microservice 4, goes down, the microservice 3 basically return some default response to a microservice 2. If this microservice 4 goes down, the microservice 3 will send some default message to microservice 2, and then microservice 1 will get the response of 2. Okay, and it will send the response to the client. That is not okay. Similarly, we have a circuit breaker pattern. Okay, if circuit breaker pattern, what happen in microservice 4 goes down, it would not allow the microservice 3 to hit the request to a microservice 4. Okay, continuously. So we can save a lots of resources. That is a circuit breaker pattern. Similarly, we have retry mechanism. In retry mechanism, microservice 3 will retry multiple time calling the microservice 4 in case of failure. Okay, slow down or failure. What is retry mechanism? If microservice 4 goes down, to microservice 3 will hit multiple time calling the microservice 4. Okay, if it is fault or slows down, that is the And what is the disadvantage of microservices? Management of large application. It is basically difficult. Communication will become difficult, and you will basically all the things will resource means you will need like in gateway large resources will be needed. Employee will be needed. Okay, then that will basically increase the costing. Okay, so basically it is costlier. Microservices costlier in the sense. Okay, so that is why. Hmm. Now coming to our next topic, this is microservice design pattern. So what are the design pattern? Basically, design pattern is nothing but a template, a way of working in a in a microservice architecture. Means, let me tell you what is design pattern. Basically, when we are working in microservices, there are some certain commonly occurring problems. Okay, to handle that problems, we basically there is a design pattern, implement to design pattern, and it will help us to work effectively without any fault tolerance. Basically, design pattern is general, reusable solution to common occurring problems in a software design. They are not specific code implementation. They are rather than a blueprint or template for how to solve a problem, allowing for a flexibility, customization to fit different situations. Design pattern promote a code reusability, maintainability, readability, make the development more effective. So there are these are basically design pattern. Like we have seen a circuit breaker is also a design pattern. Okay. Let me go one by one. You can understand slowly what I am saying. Like characteristic of design pattern, it can be reusable, can use a different project, proven, developed from a real world experience, language independent, improve the code reusability and maintainability. That's it. Characteristic types of design pattern, well, like general software engineering, which we have used. Creational design pattern is how the object can be created with singleton class. You can create factory method and builder method. You can create a structural pattern, how objects are structured and connected, adapter, fedake, and proxy. Behavioral pattern, how the object interact with each other, like observer, strategy, and commands. So in microservice, design pattern are applied at architectural and system level, not just in a code. For example, we have seen circuit breaker. This is the common problem, like microservices failing. Then what design pattern you use? Circuit breaker you can use. API gateway for routing the request. Okay, that is also a design. Okay. These are basically implementing those things in our microservice architecture. This microservice architecture, we are implementing the design pattern to common agreed problem. Like for fault tolerance, a circuit breaker, request rate limiting, authentication, everything, API gate. Okay, that is event sourcing for messaging state. This so types of different types of design pattern, resilience pattern. Okay, then we have a circuit breaker. Okay, retry pattern. Okay, timeout pattern, bulkhead pattern. Okay, these are in when we develop an application in microservice, we will use circuit breaker, retry pattern. Okay, we will use API gateway, circuit breaker pattern. Okay, this we will basically use. Okay. Then we have a CQRS, command query response strategy. That split the query, write the command operation, improve the performance and scale. This is basically used for improving the performance and scalability. Data consistency, with the help of CQRS, command query responsibility segregation, it improves the performance, scalability, and data consistency. Okay. Then integration pattern, we have seen API gateway pattern we basically use. Okay. Spring Cloud Jenkins, we will basically use. That is the thing. Now, coming to our Kafka. So, in asynchronous communication, we have seen we can do with the help of a Kafka and RabbitMQ are the two things for asynchronous communication. So, what is basically a Kafka? Kafka is an open source distribution event streaming platform. It is used to send, store, receive a real-time data stream like message. Okay, connect different parts of the system using a publishing and subscribing to message or topic. Kafka is often used in microservice architecture for asynchronous communication. So basically, a Kafka, like we have a producer and consumer. In between producer and consumer, we want to communicate with the help of message. So we will use a Kafka or RabbitMQ. So Kafka is basically used to collect a big data, conduct a real-time analysis, okay, and process real-time stream of data. It has the power to do all the three in the same time. The Kafka is open source stream processing software platform which is basically used to handle a real-time data storage. Okay, so that is the basically a Kafka. Okay. Apache Kafka is like a communication system that help different parts of the computer system to exchange the data by publishing and subscribing to the topics. Okay, like this is example of the Kafka, like in a e-commerce system, like the order service, basically create the order. Payment service listen to the event, this event, and start processing the payment. Okay. The communication happen through these two. This is the order service, payment service. In this between there is a Kafka. Okay. A order service basically create the order. That is you can call event or message or create a topic. Then okay, this is basically producer, order service is a producer, and payment service is a consumer. Okay, in between there's a Kafka. Okay, producer will produce the services, consumer will consume the services. Okay, the consumer will subscribe to the topic. Okay, that is a Kafka. Okay, publish and subscribe. Okay, that is called producer will produce the thing, publish the thing. So it is publisher, and consumer will consume the thing. Okay, how it will consume? It will basically subscribe to the Kafka topics. Okay, communicate with the help of Kafka topics, MSS. Okay, yeah, Kafka in simple term. Okay, so that is a Kafka. So before moving to Kafka architecture, this is a Kafka architecture. We have producer, consumer, and topics. The producer basically. Let me first why we are basically using Kafka, because it have high throughput, it is fault tolerance, durable, scalable. In Kafka architecture, we have a producer and consumer. Producer, it is one which is producing topics, message. Okay. Consumer is one which is consuming the message and topic with the help of subscribing to the Kafka. Yes, subscribing to the topics. Yes, subscribing. Okay. So producer is an application that send or publish data message to a Kafka. Okay. Here is a this is called order service producer. Here in between there is a Kafka. It will produce send a message to a Kafka. Okay. And consumer is an application that read how it will basically read. It will subscribe to the topic, subscribe the Kafka, subscribe the message, which basically in between the producer and consumer, which will take the message from the Kafka. Okay. Consumer will is the application that subscribe to the topic's message. Okay, and it will basically consume the message from the Kafka. Example, payment service read the order basically. Okay. What is topic? Basically, a topic is like a category or a folder to store the message. Topic is what? Like we have generated a message. We have given a separate name and we folder where these messages are basically stored. And this consumer basically consume the message with the help of the topic. The producer send the data to a topic and consumer read it. Okay. Topic can be divided in basically furthermore, the topic can be divided into the further partition. Means there is a one folder like let me understand this. Well, in system you have a folder. Inside folder you have a file. Similarly, here we have a topics. Inside topics we have a partition. So we can store different partition one, partition two, partition three. Different messages can be stored in different partition. Okay, simple way. Then what is partition? A partition is a log where messages are stored in a sequence. Okay, sequence means one term there is called offset. The offset is basically a sequential number to a message. Okay. So partition allow the Kafka to scale horizontally, that is parallel processing. Okay. In between, we have a broker. In Kafka architecture, we have a broker also. A broker is a Kafka. Simply broker, what you understand in simple term, a broker is a Kafka server that store the message. Okay. That basically store the message and serve to a cloud. Okay. Kafka. And then in Kafka broker, there is a let me understand one more thing. There is a Kafka cluster usually has a multi first not this. Where is the example? Oh, this is a Kafka cluster. Inside Kafka cluster, you will have the broker. Okay, and inside the broker, you will have the topic, and inside the topic, you have partition one, partition two, partition three. So let me explain one more thing. This is a basically this all is a Kafka architecture. Okay, this okay, and this is a Kafka ecosystem. Inside Kafka ecosystem, you have a zookeeper. Zookeeper basically will help us to run the Kafka. When you want to implement the Kafka, first you have to run the zookeeper. Okay, so first thing is this is under Kafka ecosystem. We have the zookeeper. You have for running the Kafka, you have to start the zookeeper first. Okay. Then you have a Kafka cluster. Inside Kafka cluster, you have a broker. Inside the broker, you have a topic. Inside the topic, you have partition one, partition two, partition three. Okay. This is a producer, consumer, producer produce the value. Consumer will first subscribe to this Kafka, and then it will receive the message with the help of the topic. Okay. And inside the topic, the message basically saved in the partition one, partition two, partition three. Okay. Data is stored in the partition and data is stored and managed with the help of the data store and managed with the help of the offset. Offset is nothing but a sequential ID number to a message. Okay. For using a Kafka, using a RabbitMQ, you have to basically download the Kafka and RabbitMQ first and start, and then you will implement and run in your application. So Kafka basically run on the port number 9092. Okay, 9092. That is, we have inside the Kafka we have a Kafka listener, which basically listen to the topic. And when we create an Kafka application, First, we create one application that is producer. We will create second application that is consumer. And producer, we create the topic. And in second application that is consumer, we will consume the topic with the help of a Kafka listener. Okay. So that we are basically going to create one application. Okay. So offset in Apache Kafka is nothing but unique identification number to a message. Okay. So what happened now here? Producer request a message to a Kafka broker. After Kafka broker, the request goes to the topic. Okay, the topic is further divided into the partition. Okay, then it is the request is sent to the consumer. Will consume the topic. Okay, now this is all we have seen. The topic is a logical name to which a record message are sent. Okay, you cannot send the data to basically a queue. Okay, you will send to a topic. And partition, what is partition? A topic is divided into a partition. Each message inside the partition has unique offset. Okay, like a message number. Partition are the reason Kafka can handle a high throughput. Data basically data is ordered only with the partition, not access particularly. Then we have a broker here. A broker is a simple and understand, a Kafka server is a broker. A Kafka then inside broker. Okay. This broker is basically inside a Kafka cluster. A Kafka cluster consists of multiple, this Kafka cluster consists of multiple broker 1, broker 2, broker 3. A broker store the data and serve it to consume with the request. Each broker is responsible for the each broker responsible for subset of partition. Because broker inside topic, then partition. Then we have consumer. Basically, consumer this will be basically subscribe to the topic or read the message. Okay, messages are pulled. Basically, the messages are pulled. The is pull message. This push the message. This is pulling the message. Okay, because it is consumer is subscribing to the Kafka. Consumer. Okay. And what is a zookeeper? I have told zookeeper basically for running the Kafka, you have to first start the zookeeper. Zookeeper used for a metadata. Basically, it is used for metadata management, leader election, or help check. Okay, Kafka now support a Kafka model, Kafka Raft also. That is the small overview of the Kafka. Okay. Now you can use the Kafka in many way like banking application, e-commerce application. Okay. For that you can use the real-time example scenario, sending order, producer. This all I have covered. Advantage of Kafka, fault tolerance, high real-time data, scalable, durable, producer and consumer. Okay. Now coming to a RabbitMQ. Okay. So what is basically a RabbitMQ? Okay. A RabbitMQ is basically an open source message broker that help to application to communicate is asynchronously by sending and receiving the message by a queue based upon the system. Okay. It it act like a post office. Okay. Produce like basic RabbitMQ. In messaging application, you will use RabbitMQ because its service is very fast. Okay. In Samsung company where I was working, there is a pretty chat application where I was working as a Java developer. There in British chat application in one internal services which are being provided by the Samsung SDS company. They are using a RabbitMQ for messaging. Okay, so a RabbitMQ is basically a open source asynchronous communication is done with the help of RabbitMQ. RabbitMQ is simple is to store the message and pass that to a consumer when it is ready. Okay, when the consumer will be ready, it can take the message. RabbitMQ can use when a web server need it. Okay, whenever you need, you can use the RabbitMQ. It is basically a quick response to the request. Okay, RabbitMQ basically use the queue. RabbitMQ is basically a queue. So messages are done away once it is consumed and acknowledge is being provided do not guarantee the atomicity even if the relation of the transaction involving a single queue. RabbitMQ, you can specific message priority. You can set this. We have seen in queue we can see a priority queue, T queue, array D queue. Okay, basically a queue is what is for storing. Okay, so RabbitMQ you can set the priority to the message. Okay, and consume the message with high priority. Okay, that is the advantage here. So what is a message queue? Message queue is allow the application to communicate by sending a message to each other. Okay, the message queue provide a temporary in RabbitMQ we basically use a queue. You can see the queue. RabbitMQ basically use the queue. Okay, the queue is used for storing the data. Okay, we have in collection we have seen what we have seen uh, set list queue. We have seen a set list queue. So that is the queue basically here. So what is here? A message RabbitMQ basically is the queue. Okay. So queue it allows the application to communicate by sending the message to each other. The message queue provide a temporary message storage when the destination program is busy or not connected. A message queue is made up of producer, a broker. A message queue basically is a software which basically store the message, and when the they are ready it will send the message. Okay, a message you provide a synchronous communication. Okay, a queue, a queue and what is queue? A queue is basically a buffer storage uh, in RabbitMQ broker to store the message. The message are put into the queue by the message are put into the queue by the producer. Okay, producer, and read it by the and then we read the message by the help of consumer. Okay, once the message is read it in a consumer, it will remove once you receive consume the message, yeah, consumer consume the message, read the message will basically remove from the queue. Okay, and what is you can also ask what is a message? Message is nothing but information that is being sent from producer to consumer. Okay. So here this is the architecture. The producer will send the message, publish the message to the exchange. Okay. In exchange, basically it this is exchange. Okay. And this is queue. The exchange is routing to the queue, and then the consumer is consuming. Okay, so let me explain what is here exchange basically means. And this is a rapid tempo between the producer and communicator. This is basically called publishing and subscribing. Okay, message queue. Okay. So exchange basically it act as a intermediate between the producer and the queue. Intermediate producer and queue intermediate exchange. Instead of sending a message directly, instead of sending a message directly to the queue, a producer can send a message to the exchange, and then exchange then send a message to one. The queue can be one or more than one queue. Okay, here is one queue, it can send to different queue can be more than one queue. Okay, following to a specific set of rules. Okay, this producer does not need to know the queue. Okay, producer does not need to know the queue that eventually receive this message. Okay, then how it is basically sending the request to the queue with the help of routing key. So routing key is a key that exchange. Exchange is basically sending the message with a routing key. So routing key is basically a key. Okay, that exchange look as to divide how to route the message to the queue. Okay, routing key with the help of routing key they are exchanging a routing a data to a queue. That is simple. Routing key is like an address for the message. Routing key is like an address. Okay, it has routing key. Then then we also have a here binding. Binding basically binding like the exchanging to a queue using a routing key. Okay. So let me first start with. here. RabbitMQ architecture, we have seen producer, we have seen queue. Queue is a very buffer memory which basically store the message, okay, and it will send to consumer when it is ready. Then consumer will basically publish, subscribe to the what? Subscribe to this your RabbitMQ. Okay. Then we have exchange. Basically, it is the working in between the producer and consumer, sending a message to queue with the help of the routing key. Okay. Then we have a binding that link and exchange to the queue using a routing key. With the help of binding, they are linking the message to a routing key. That is binding. Okay, basically help us to bind the message to the queue. Okay, okay, bind. Okay. Now, how RabbitMQ basically works? Okay, like producer sending something to the exchange. It will go to exchange. From exchange, it will go to the queue. From queue, it will go to the consumer. Order place, send in. Oh, we want to place that order, then it will go to send email. Okay, send. After placing order, the email will be sent. Okay, so they are two different services. The producer, it is an order service. Send a message to the exchange with a routing key. Order dot create. Then exchange check with a queue is bound to it using the routing key. Then message is sent to a message queue like the email dot queue. Okay, it is stored in this format. Then consumer, that is email service. This is second service. Read the message from the queue, read the message from the queue and process it and send the message. Okay, send the message. So, so that is the basically act. This is the basically a how the working in inside RabbitMQ architecture. So let me explain one more time. There will be a producer, that application or a service that send the message. Okay, it basically do not send directly to the queue. We will have an in between exchange. It will not directly, we have exchange here. Okay, then after what exchange decide how to route the message to a queue. Okay, exchange basically here. Exchange basically decide how to route a message with the queue with the help of binding and routing key. It's exchange the message to the queue. Okay, then exchange can be direct top with the help of topic. Okay, with the help of header. Okay, then we have a queue basically a buffer memory. Okay, which store the message until it is consumed by the consumer. Okay, the messages are held here until the consumer basically pick up the message. Okay, until unless the consumer pick up, it will basically store in the queue only. You can have a multiple queue inside the here. Then consumer is application or service that receive the message and can acknowledge the message processing. Okay, and and here also there is a broker part also here in RabbitMQ. A broker is a what? A RabbitMQ server. Okay, that manage the exchange, queue, and binding and messaging delivery. And RabbitMQ also is broker. And RabbitMQ and Kafka, there are broker. Broker are basically a servers. Okay, that manage the exchange and queue. Okay, routing in the so that is all. So I think now you are clear about what are the microservice, what are different types of microservice architecture, what basically design, what is design pattern, what is the role of design pattern, and what design pattern we are going to use. We are use circuit breaker, API gateway that will basically solve the common problem in microservices. Then we have seen a Kafka architecture, flow diagrams, RabbitMQ definition, architecture, flow diagram, and request. So this is all. This is the theoretical part of microservices. Hope you would understand. Now, in next classes, we are going to create one microservices, asynchronous application of microservice where we will use REST template and open Figma or web client to communicate between the two microservices. And next we create another application where we will use a Kafka to communicate between the two microservices. Okay. For that, we have to install the Kafka in your desktop. Then you have to start the zookeeper. With the help of Jupyter, you will start your Kafka, then you will start your application and publish and subscribe to the topic. Okay, this is it. So thank you all, see you in the next session. Thank you, bye bye, tata.